Well, dear student, now heading is photoconductivity of semiconductors. Lot of things has been said about conductivity of semiconductors. The conductivity of semiconductors increase due to temperature. It also varies with impurity added. It depends on electron hole mobility and so many things. Now this is another thing here. If a semiconductor is exposed to light photons having energy more than the energy more than the value of energy gap between valence band and conduction band. Then by taking energy of photons, electrons may jump from valence band to conduction band. So when number of electron increase in conduction band and hole in valence band, then conductivity increases. And the conductivity of semiconductor entirely depends upon the number of electrons in conduction band and hole in valence band. So as a result of this, conductivity of semiconductors increases, and this conductivity shown by semiconductor, the conductivity of semiconductor the conductive semiconductor, due to light falling on them, is called photoconductivity. Photoconductivity. Silicon, has energy gap between valence band and conduction in 1.1 electron volt. Silicon silicon has energy gap between valence band and conduction band of 1 electron volt, and visible light has energy gap, energy of visible light varies from 3 electron volt violet color to 1.8 electron volt for red color. So silicon absorb light easily. So when silicon is exposed to light, its conductivity also increases. And this is the fundamental fact using photocell, and which you say, nowadays which is also a source of light, solar cells, solar panel. We are using solar panel to generate electricity from sunlight. So this is that principle here. If light photon having energy more than energy gap between valence band and conduction band are incident on semiconductors, then they create electron hole pairs, because electron can take energy from photon and jump across the energy gap to go into valence band, thereby increasing the conductivity. We will take it later on while explaining the semiconductor devices. So I hope you have got what is photoconductivity and what is the reason. Simple reason is that light photon has energy varying from 3 electron volt nearly to 1.8 electron volt, and energy gap between semiconductor less than 3 electron volt. Silicon, there are more, like lead sulfide has energy gap only 0.85, but that does not absorb light easily, that reflects. So the semiconductor silicon is best source of making solar panels. Now I want to solve some question here for your simplicity, for your convenience. There is a question here. Pure silicon Si at 300 Kelvin has equal number of electrons Ne and hole NH, which is equal to 1.5 10 to the power 16 per meter cube. By doping it with indium, the whole concentration the whole concentration increases to 4.5 10 to the power 22 per meter cube. Calculate Ne in doped semiconductor and doped silicon. Silicon has equal number of holes and electron. This, when doped with indium, whole concentration become this. So you can calculate number of electron in doped silicon. We know for every semiconductor solution, for every semiconductor, Ne into NH equal to Ni square. Ni square is called here intrinsic charge carrier density, which is due to in pure semiconductor number of electrons and holes, I have told you, are equal, and that number of electron hole equal, and the number of electron hole concentration is called intrinsic charge carrier density, and there I would get Ne into NH equal to Ni square. So here you want Ne. NH now has become 4.5 10 to the power 22. Or Ni is 1.5. 1.5. Ni 1.5 10 to the power 16 square. So what is yes. So what is Ne now? Ne is equal to square of this 2.25 10 to the power 32 upon 4.5 into 10 to the power 22. So power left 22.5 upon 45 into 10 to the power 10, or you can divide it. You can take here 22.25 upon 45 into 10 to the power 9. So 225 divided by 45. 5 25. Yes. So it is 5 into 10 to the power 9 per meter cube. Per meter cube. So this way you can practice. Actually, when you practice, you get the concept clear. Now there is another question here. So here majority of majority of hole is greater than electron concentration. Now pure germanium for next question. Pure germanium. N is equal to NH, which is equal to 2.4 10 to the power 19, 4.5 10 to the power 19 per meter cube. Per meter cube for pure germanium. It is doped by indium with one doped. Pure germanium doped with indium at rate of 1 part per million. 1 part per million. Calculate the conductivity. कहता है calculate the conductivity of doped germanium. Given that number given that number of germanium atoms per meter cube is equal to 4.4 10 to the power 28, and mu is equal to 0.39 meter square per volt per second. Mu s is equal to 0.19 meter square volt per second. So you are asked here the conductivity of doped silicon germanium. Now you know that sigma is equal to n लगता है मेरे से कुछ गलत हुआ है. E N E mu E plus NH mu H. So we need NH mu H Ne mu E. So here you are given this. So number this germanium is doped with indium. Indium is trivalent atom, and trivalent atom produce holes. तो number of holes जो है equal to number of acceptor atom, and that is equal to 4.4 into 10 to the power 28 upon 10 to the power 6. Why? You are told that 1 part per million means with 10 to the power 6 atom of silicon or germanium, only 1 atom of indium is added. So this number come out to be 4.4 10 to the power 22. It is number of holes. Now Ne into NH equal to Ni square. This is here Ni. So Ne into NH 4.4 10 to the power 22 Ni square. 4.5 into 10 to the power 19 square. So you will get here N equal to 4.4. 4.5 into 4.5 into 10 to the power 38 upon 4.4 into 10 to the power 22. So nearly it is 4.5 10 to the power 16. So number of electron is nearly 4.5 10 to the power. Now you know sigma equal to E into Ne into Be. Mu H, mu E plus NH into mu H. Here NH 10 to the power 22, it is 16. If you have 10 to the power 22 with 10 to the power 16, so this number is negligibly small. So here N is small, so it will be E into NH into mu H. So E 1.6 10 to the power 19, NH 4.4 10 to the power 22, or mu E 0.19. You can multiply and get it 1.6 into 4.4 into 0.19 10 to the power 3, and it comes out to be 1.34 10 to the power 3 conductivity per ohm per meter. By the conductivity is equal to resistivity. Resistivity unit ohm meter. It is ohm per meter. So I think you might have got this question. And please try such question this way. Thank you.